Okay, I'm just going to wrap this one up with a few notes about affricates. So affricates, they work kind of exactly the way you'd expect acoustically. So affricates are stop fricative sequences like ch and j. Acoustically, the only thing that's kind of a surprise about this is that amplitude rises faster in affricates than in plain fricatives. So if you think about it, if you have, say, a voiceless affricate like ch, the T is just going to be silence during the closure of the stop, and then after it, you'll see a fricative, which has turbulence, and then if it's sh, it's going to have the relevant energy at the relevant frequencies. When I talk about amplitude rising faster, all I'm talking about is going from silence to the maximum amount of intensity in the fricative part of the affricate. And in an affricate, that happens a lot more quickly than it happens if you're just going from a regular stop to a regular fricative. Yeah, so I can't think of a particular example that would be good to talk about in English, but I'll show you an example in Polish here in a second, because Polish actually makes this distinction between a stop fricative and affricate sequence. So yeah. Some affricate typology data, just for kicks. In the 316 languages in the UPSID database, there are 522 affricates. The most common one is ch. Second most common one is ch. So we're seeing a similar sort of pattern as we saw for fricatives, where you get more voiceless affricates than voiced affricates. But the third most common option is j, and then z. So 80 to 141 at the post-alveolar place of articulation, and then 30 to 95 at the alveolar place of articulation. Not much beyond that. Most affricates in the world are going to be sibilants or have sibilant fricatives in them. So 485 out of 522 are going to be like that. However, you do find some kind of common patterns in the other fricatives that are not sibilants. So like German has a pf fricative, which is like labial dental. Lots of languages have like th fricatives, like Navajo, so on and so forth. So there's no sibilants there. And you still get them. Just to show you kind of what the amplitude rise time is about, this is
shy, chime, shy, chime.
So the ch in chime is supposed to go from the silent part in the T to the peak of the amplitude a little more quickly than this fricative sequence in shy.
Shy, chime.
And the whole affricate kind of goes by a lot more quickly in this chime example, or at least the fricative goes by more quickly if it's in part of an affricate than it does if it's part of just being itself. Like I said, Polish contrasts stop fricative sequences with affricates at the exact same place of articulation. So here's the word 3 in Polish.
Trzy.
And here's the in Polish, if you want to ask a question, you just put a little word in it to denote that word in the sentence to denote the whole thing's a question without doing anything else with the syntax. That's a question particle. Here's what it sounds like.
Trzy.
So 3,
Trzy.
question particle.
Trzy.
And this is the word for idle.
Trzy.
So that's kind of fun too, but this is not, this ch is not the same thing as this ch.
Trzy. Trzy.
It goes by a little more quickly. You can look at this in spectrogram view. Unfortunately, this has some noise in the background, so it's not ideal, but this is the stop fricative.
Trzy.
And you can see, again, this fricative lasts a lot longer than if it's just a question particle.
Trzy.
And this is actually a little bit more intense too, even though we can't see the waveform. Also, again, this is our sh, retroflex fricative, so we're getting sibilants here. We're getting a lot of intensity at the higher end of the frequency scale. Okay, so just to wrap this whole thing up, for fricatives, turbulence is going to provide the source of fricative noise, sort of like parallel to the way that voicing provided the source of sound for vowels or other periodic sounds, as we'll see later. So fricatives are turbulent or noisy things. Voiced fricatives are also going to have that sound source at the glottis, so they're going to have two different sound sources. Obstacle turbulence will tend to be louder than channel turbulence, so a fricative like s is going to be louder than a fricative like h. Sibilants are particularly high in intensity. I just realized that I misspelled the word particularly here. I'll have to fix that before I post these notes. because sibilants are excellent obstacle fricatives because they use the front of the tongue to direct the flow of air at the back of the upper row of teeth, creating quite a lot of noise, so on and so forth. The filter of fricative turbulence will change depending on the place of articulation. So if you have a sibilant, you have a very short filter that emphasizes the high frequencies. If you have labials like the f, you remember those have a diffuse spectrum with weak energy all across the board. It's because there's not much of a filter to work with there. You're just kind of letting it go out into the outside world without emphasizing particular frequencies, using the non-existent filter in front of the f constriction. Back fricatives like the glottal fricatives h and h are going to look a lot more like vowels. They're going to show formants at the appropriate frequencies, but otherwise just have the turbulent noise as kind of their source, so they won't be periodic for that reason. Affricates have stop fricative sequences with shorter rise time, and the fricative parts of those tend to be shorter than regular fricatives as well. And that's the primary things you need to know about fricative acoustics. We'll do some spectrogram matching exercises with fricatives. The sibilants tend to be pretty easy to pick out. Fricatives in general are pretty easy to pick out because there's just a lot of noise in the midst of the flow of speech. So this will kind of give us a leg up on trying to decipher more complicated stretches of speech when we look at how to read entire sentences in spectrograms. Okay, I'm going to stop there before I ramble on too long. I'll see you next time.